Welcome to Do the Math America. I am Charlene, Math Shaman. This lesson is on perimeter and area of polygons from pages 262 to 266 of the New Elementary Mathematics Syllabus 1 book. Please find a copy of this book from singaporemath.com. Perimeter and area of polygons. A polygon is a closed two-dimensional shape formed by connecting straight line segments at their endpoints. The key features of a polygon: it has sides, the line segments that make up the polygon. Vertices are the points where the sides meet. They are closed, the shape must be completely closed, and they have straight sides. The sides must be straight lines. And they have at least 3 sides and 3 angles. Examples of polygons are triangles, squares, rectangles. A pentagon is a polygon. Penta means 5 because it has 5 sides and 5 angles. Hexagon is a polygon with 6 sides and 6 angles. Hexa means 6, and the tri in triangle means 3. An octagon is a polygon with 8 sides and angles. Octa means 8. And here I show you the number of sides in these polygons. The perimeter of a figure is the distance around its sides. So for example, here we have a rectangle. The perimeter of the rectangle would be the sum of its sides. So we add up the 2 lengths, which are the longer sides, and the widths, which are the shorter sides. In a rectangle, the 2 lengths are the same, as are the 2 widths, and all 4 angles are right angles. That is, they are 90 degrees. Formula for a perimeter of a rectangle, therefore, is length plus width, or 2 times length plus width. And you notice the length plus width are in a parenthesis, which means that must be calculated first before you multiply by 2. The other way to think of it is the perimeter of a polygon is the sum of the sides. And that is true regardless of the number of sides or angles of the polygon. When we compare the size of a football field to that of a tennis court, we notice that the football field is larger. We say that the football field has a larger area than the tennis court. We use square regions as units for measuring area. Squares can be considered a special kind of rectangle in which all sides are the same. If each side of a square is 1 centimeter in length, the unit is a square centimeter, written as 1 cm square. A square has 4 equal sides, and the area of a square is found by multiplying side times side. So in this case, you would multiply 1 centimeter by 1 centimeter to get 1 centimeter square. The area of a square with the length of 1 meter would be 1 meter times 1 meter, which equals 1 meter square. A square with the length of 1 millimeter would have an area of 1 millimeter times 1 millimeter, which equals 1 millimeter square. A square with the side of 1 inch would have an area of 1 inch times 1 inch, which equals 1 inch square, or 1 square inch. A square with the side of 1 foot would have an area of 1 foot times 1 foot, which equals 1 foot square, or 1 square foot. This figure is an enlarged square that is 1 centimeter by 1 centimeter. 1 centimeter equals 10 millimeters, So 1 centimeter square equals 10 millimeters times 10 millimeters, which equals 100 millimeters square. 1 millimeter square equals 0.01 centimeters square, or 1/100th centimeter square. This rectangle has a length of 5 centimeters and a width of 3 centimeters. That is, each tiny square within has a side of 1 centimeters. So the area of the tiny squares would be 1 centimeter square. That is, each square that makes up the rectangle has an area of 1 centimeter square. Because you multiply the two sides together, 1 centimeter times 1 centimeter to get 1 centimeter square. The formula for the area of a rectangle is length times width. In this case, it would be 5 centimeters times 3 centimeters, which equals 15 centimeters square. The area of any figure is always a square unit. It's good to memorize the formula for the area of a rectangle as length times width. This rectangle has a length of 2.4 centimeters and a width of 1.7 centimeters. So its area would be calculated as 2.4 centimeters times 1.7 centimeters. I do that calculation on the side, 2.4 times 1.7. For a refresher on how to multiply decimals, please watch my video, Lesson 17, Multiplying Decimals, at Do the Math America. Once we've calculated 24 times 17, we need to count how many decimal places. In the factors 2.4 and 1.7, there are 2 decimal places, so we move the decimal point 2 places to the left to give us 4.08. And we must also multiply centimeter times centimeter to get centimeter square. This rectangle is 4.08 centimeters square. And we box our answer. To convert the area from centimeters to millimeters, we do the following. Recall that 1 centimeters equals 10 millimeters. So 2.4 centimeters would be 24 millimeters. That is, you multiply 2.4 times 10. To convert 1.7 centimeters to millimeters, we multiply 1.7 times 10 to get 17 millimeters. Now we can calculate the area of that rectangle using the length as 24 millimeters and the width as 17 millimeters. So the area would be length times width, or 24 times 17, which equals 408. Millimeters times millimeters equals millimeters square. So the area of that rectangle in millimeters would be 408 millimeters square, and we box our answer. Here we have 2 rectangles approximately the same size, and you can refer to the bottom side of each rectangle as the base. The sides perpendicular to the base would be called the height of the rectangles. In this case, the area of the rectangles could be calculated as base times height, which is another way of saying length times width. They both would give you the same answer for the area of the rectangle. Let's examine this parallelogram from page 333 of the textbook. A parallelogram is a four-sided figure with parallel opposing sides. In this figure, the dotted lines show how the parallelogram is cut and put together to form a rectangle. And we can see that the parallelogram ABCD is equal in area to the newly formed rectangle MDCN. The area of the parallelogram ABCD would be calculated as NC, or the height of the perpendicular side of the rectangle, times DC, the base of the sides of both the parallelogram and the rectangle. Any side of a parallelogram can be taken as a base, and the perpendicular from a point on the opposite side to the base is called the height of the parallelogram for that base. So the area of a parallelogram is calculated as base times height. I want you to take note that the side of the parallelogram, BC, the slanted side, is not perpendicular to the base, and therefore it cannot be used as the height to calculate the area of the parallelogram. So here I use some blocks put together to show you a parallelogram. If I take the left-hand triangle and match it to the right-hand triangle, I make a rectangle. Both the parallelogram and the rectangle, in this case, have the same area. So I'll just show you what I mean. I shift the triangle from one side of the parallelogram and match it to the other triangle, and now I have a rectangle with the same area as when it was a parallelogram. Please note that this parallelogram, which has been cut and rearranged into a rectangle of the same area, is not the same as a parallelogram that has been straightened up into a rectangle. As you can see here, the parallelogram that was straightened up into a rectangle does not have the same height. The parallelogram has a shorter height than the rectangle. So, for example, if we examine this rectangle and parallelogram, these two figures do not have the same area. Their bases are the same length, and the height of the rectangle has the same unit of measurements as the length of the parallelogram side. As you can see, when I use my ruler, they both have sides that have 5 units in length. So even though the rectangle and the parallelogram share a base length that's the same, and the height of the rectangle is the same as the length of the parallelogram, they do not have the same area. The area of the rectangle is base times height, but the area of the parallelogram is base times altitude, and that altitude is found from the base and the perpendicular from a point on the opposite side of the base. The area of this parallelogram will be less than the area of the rectangle, since the altitude of the parallelogram is shorter than the height of the rectangle. Triangle ABC is an acute angled triangle. If an identical copy of triangle ABC is inverted and placed alongside triangle ABC to form a parallelogram as shown, we can see that triangle ABC is half the size of the parallelogram. This I will demonstrate using my origami triangles. So here is an acute angled triangle, and then when I make a second identical sized triangle, I can place them in such a way that they form a parallelogram. The altitude of the lower triangle is the perpendicular from the base to the opposite angle. The area of the parallelogram would then be calculated as base times altitude, and the area of the triangle would be 1/2 times base times altitude. So to reiterate, the area of a triangle equals 1/2 times base times height. And the height is the perpendicular from the base to the opposite angle. Unless a triangle is a right-angled triangle, the height is not either of the two other sides of the triangle. You can see in this case, neither of those sides are perpendicular to the base. Now, any side of the triangle can be taken as the base of the triangle, and the altitude or the height would be the perpendicular to the opposite angle of the triangle. So if I use the right side of this triangle as the base, then the altitude or the height would be the perpendicular to the opposite angle of the base. So I've drawn a perpendicular to the base here, to the opposite angle in the triangle, and that would be the altitude or the height of the triangle. So you could also calculate the area of this triangle using the right side as the base and the length of its perpendicular to its opposite angle as the height, using the equation 1/2 times base times height. You would get the same measurement for the area of this triangle if you use the left side of the triangle as its base, and the height would then be the length of the perpendicular drawn to its opposite angle, using the formula 1/2 times base times height. The formula for the area of a triangle is 1/2 times base times height and applies even to obtuse angled triangles like this one, triangle ABC. So if I take an obtuse angled triangle and make an identical one and line them up to form a parallelogram, I can see that the area of that obtuse triangle is 1/2 of the area of the parallelogram. To find the area of the triangle, we would use the formula 1/2 times base times height. And again, any side of the triangle can be used as its base. And in this triangle, the perpendicular to the opposite angle is the height. And once again, the area of the triangle is 1/2 times base times height. If I were to use the right side as the base, then the height would be the perpendicular from the opposite angle to the base. So I draw a line that is parallel to the base from the vertex of the opposite angle, and then I draw a perpendicular line that connects the two, and that would be my height that I would use to determine the area of the triangle. If I were to use the left side as the base to calculate the area of the triangle, I would use the vertex of its opposite angle to draw out a parallel line to the base, and then draw a perpendicular line to connect both the base to its parallel line, touches the vertex of its opposite angle, and that would be the altitude or the height that I would use to plug into the formula 1/2 times base times height. You can also extend out the base line so that it matches the other parallel line and draw a perpendicular down that to connect at the vertex of the opposite angle. And that perpendicular line would be the height, which you would use to plug into the formula 1/2 base times height to get the area of the triangle. Okay, back to the textbook. A trapezium is a four-sided figure which has a pair of parallel sides. PQRS is a trapezium with PQ equal A units and SR equals B units. The height of the trapezium is H units. You can see here that if an exact copy of the trapezium is inverted and placed alongside the original figure to form a parallelogram as shown, SY is the base of the parallelogram. And you can see that SY equals A plus B units. So then the area of the parallelogram is A plus B times H square units. And we can also see that the trapezium PQRS is half the size of the parallelogram. Thus, the area of the trapezium is 1/2 times H times A plus B square units. And the A plus B must be added first, for we multiply by H the height and by 1/2. And I will illustrate this using my origami trapeziums. If we invert the same size trapezium next to the original trapezium, we create a parallelogram. And here I will just summarize the area of a trapezium. The top and bottom lines are parallel, and there is a perpendicular from the base to the top line, parallel line. And the top line measures A, and the bottom line measures B, and the perpendicular is the height as H. So the formula for the area of a trapezium is A for area equals 1/2 times height times, in parenthesis, A plus B. The area of a rectangle is 64 centimeters square. If its length is 16 centimeters, find its perimeter. So first we write the formula for the area of a rectangle, which is length times width. And then we make note that it is given that the area of the rectangle is 64 centimeters square. So 64 centimeters square equals the length, which is 16 centimeters, times the width. So now we solve for the width of the rectangle. I will just substitute W for width. To solve for W, we divide both sides of the equation with 16 centimeters. So on the right-hand side of the equation, we have 16 centimeters times W divided by 16 centimeters. And on the left-hand side, we have 64 centimeters squared divided by 16 centimeters. On the right-hand side, 16 centimeters divided by 16 centimeters equals 1, and 1 times W equals W by itself. And on the left-hand side, we have 64 divided by 16, which I do on the side. 64 divided by 16 equals 4. I go back to the equation and write 4 underneath 64 divided by 16, and now I work on the units. Centimeters squared divided by centimeters equals centimeters. So W, or the width, equals 4 centimeters. Now I go back to my rectangle and label the width with 4 centimeters so I can reassess the problem. And what I need to do now is to find its perimeter. And the perimeter of a rectangle equals the sum of its sides. So I just go back to my rectangle and label all the lengths of its sides and add up those sides, and I will get the perimeter. So the two lengths are 16 centimeters and the two widths are 4 centimeters. So I have 16 plus 4 plus 4, which equals 40. So the perimeter is 40 centimeters. And I box my answer. Please note that the perimeter of any figure is always a singular unit, whether it is measured in centimeters or meters or inches or feet. It is always a singular unit. So in this case, 40 centimeters. It is not a square unit, as you would calculate in an area of a figure. Just keep that in mind, that perimeters are in singular units and areas are in square units. In the figure, AD and EC are altitudes of triangle ABC. If AD equals 5 centimeters, BC equals 12 centimeters, and AB equals 10 centimeters, find CE. So I write given AD and EC are altitudes of triangle ABC. Next, I go back to the figure and label it with all the facts that are given. So AD equals 5 centimeters. The base BC equals 12 centimeters. And the side AB equals 10 centimeters. Always use a straight edge to reproduce the figure on a piece of paper using pencil and paper. And try to reproduce the figure as closely as possible. You don't need to use a protractor, but you should try to make an approximation of the figure. If you try to just freehand draw the figure, you will find it much more difficult to solve the problem because it's hard to see the figure clearly. The lengths of a figure drawn freehand will not make as much sense as one drawn with a straight edge. In this problem, we need to solve for CE, which I will label as H for height. CE is the height of the triangle if the base is AB. That is the side that is 10 centimeters. But if we use the side BC as the base, the 12 centimeters side, we can figure out the area of triangle ABC by using 1/2 times base times height. The base would be 12 centimeters and the height would be 5 centimeters, or AD. So I rewrite that equation. Area of triangle ABC equals 1/2 times 12 centimeters times 5 centimeters. And I go back to the figure and highlight the sides which I am talking about. So BC would be the base and AD would be the height that I'm using for this formula. So now it's just a matter of simplifying. 1/2 times 12 times 5. 12 times 5 equals 60, and 1/2 of 60 equals 30. So the area of triangle ABC is 30 centimeters square, because I must also multiply the units centimeter times centimeter to get centimeters squared. Now that I have figured out the area of triangle ABC, I can use the formula for the area of the triangle, 1/2 times base times height, and use side AB, the 10 centimeter side, as the base in order to figure out H. or side CE, which would be the height or the altitude for that side. So I use my green marker to highlight the sides which I am referring to. So side AB would be used as the base, and side CE or H would be used as the height of the triangle. And since I already know that the area is 30 centimeters square, I will just plug those values into the formula to solve for CE. So that gives me 30 centimeters square equals 1/2 times base, which is side AB, times side CE. I rewrite this equation on the next line as 30 centimeters square equals 1/2 times 10 centimeters times CE. And I simplify. 1/2 goes into 10 5 times, so I bring it down to the next line. 5 centimeters times CE equals 30 centimeters square. To isolate CE by itself, I divide both sides of the equation with 5 centimeters. So on the right-hand side, 5 centimeters times CE divided by 5 centimeters. And on the left-hand side, I have 30 centimeters squared divided by 5 centimeters. On the right-hand side, 5 centimeters divided by 5 centimeters equals 1. 1 times CE is CE by itself. And then on the left-hand side of the equation, I continue the calculation on the upper left. So I have 30 centimeters squared divided by 5 centimeters equals CE. 30 divided by 5 is 6, and centimeter squared divided by centimeter is just centimeter. So I have 6 centimeters equals CE, or CE equals 6 centimeters. And I can also call it H equals 6 centimeters, and I box my answer. Now we have an exercise converting metric units. And in math, the best way to get good at a skill is to do lots of practice problems. So here we have 5 practice problems, and we need to express 5.5 centimeters square in meters square. So first, we remember that 1 meter equals 100 centimeters. So how many meters is 1 centimeter? Well, we divide 100 centimeters by 100 to get 1 centimeter, and we divide 1 meter by 100. So we move that decimal 0.2 spaces to the left to get 0.01 meters. So 1 centimeter equals 0.01 meters. Now we're ready to begin the conversion. So 5.5 centimeters square we can think of as 5.5 centimeters times 1 centimeter. And 1 centimeter, as we looked at earlier, equals 0.01 meters. So under 1 centimeter, we write 0.01 meters. To convert 5.5 centimeters into meters, we divide 5.5 by 100. That is, we move the decimal point 2 scoops to the left to get 0.055 meters. So now I rewrite this equation on the line below without the scoops so that I can see the numbers clearly. I have 0.055 meters times 0.01 meters. And I do that calculation on the side. 0.055 times 0.01. 1 times 55 is 55, And now I just need to add up the decimal places from both factors. There are a total of 5 decimal places, so I need to move that decimal point 5 scoops to the left and add the zeros on top of those egg cups. So I end up with 0.00055 meters square. So 5.5 centimeters square equals 0.00055 meters square, and I box my answer. Problem B, express 1 millimeter square in centimeters square. I copy down that problem nice and neat, and then I remember that 1 centimeter equals 10 millimeters. Then I break down 1 millimeter square to be 1 millimeter times 1 millimeter. From the top conversion, 1 centimeter equals 10 millimeters, I can calculate that 1 millimeter would be 1/10 centimeters, because I move that decimal point 1 scoop to the left to get 1/10 centimeters. So 1 millimeter equals 0.1 centimeters, or 1/10 centimeter. And I go back to my equation and write underneath 1 millimeter, I would have 1/10 centimeter times 1/10 centimeter. 1/10 times 1/10, I do that calculation to the side, and I get 1 times 1, which equals 1, and I have 2 positions to move the decimal point from those factors. And I take that decimal point from the product 1 and I move it 2 scoops to the left and add a 0 in the scoop. So now I have 0.01, or 1/100th centimeter square. 1 millimeter square equals 1/100th centimeter square, and I box my answer. Problem C. Express 25 meters square in kilometers square. I write that problem down nice and neat, and I write down the conversion units. 1 kilometer equals 1,000 meters. So then 1 meter would be 1 kilometer divided by 1,000. So I take the decimal point behind 1 and bring it 3 scoops over to the left to divide by 1,000. And I add zeros on top of those scoops to get 0.001 kilometer. So 1 meter equals 0.001 kilometer, or 1/1000th kilometer. Now I go back to 25 meters square, and I break that down into 25 meters times 1 meter. So 25 meters square equals 25 meters times 1 meter. And 1 meter equals 1/1000th kilometer, or 0.001 kilometer, which I write on the line below. Now 25 meters converted to kilometers, I need to divide 25 by 1,000. So I take the decimal point behind the 5 and bring it 3 scoops to the left and add a 0 on top of the scoop. So now I have 0.025 kilometers, or 25 1,000th kilometer. So 25 meters square equals 25 thousandths kilometer times 1/1000th kilometer. And I write that equation on the line below so that I can see the numbers without the scoops. being visually confusing. And I do that calculation on the side, 0.025 times 0.001. 1 times 25 is 25, and now I count how many decimal places I need to move the decimal point. The two factors have a total of 6 decimal places, so I take the decimal point behind 5 on the product and I move it 6 scoops to the left, and I fill up those scoops, empty scoops, with zeros to get 0.0000025. So there will be 4 total zeros, and then 25. Make sure you don't lose any of the zeros when you are transcribing the numbers. And then kilometers times kilometers equals kilometer square. So 25 meters square equals 0.0000025 kilometers square, and I box my answer. Problem D. Express 15 kilometers square in air, abbreviated as A, where 1 air equals 100 meters square. Since I live in the United States, I've never encountered the unit air before, but math is universal, so we will use mathematical principles to solve this conversion. So first, we remember that 1 kilometer equals 1,000 meters. Next, I break down 15 kilometers square to equal 15 kilometers times 1 kilometer. Since 1 kilometer equals 1,000 meters, I write 1,000 meters on the line below, as I need to convert kilometers to meters in order to convert from meter square to air. So 1 kilometer equals 1,000 meters. 15 kilometers equals 15 times 1,000 meters. So 15 times 1,000 meters equals 15,000 meters. And I write 15,000 meters on the line below 15 kilometers to continue the calculations. So 15 kilometers equals 15,000 meters. So now I have 15,000 meters times 1,000 meters. I do that calculation on the side, 15,000 times 1,000. So anytime you multiply a number by 1,000, you just bring the decimal point 3 places to the right. That is 3 scoops to the right, and you fill in those scoops with zeros. So now I have 15 and 6 zeros behind it, which gives me 15 million. And I go back to the problem. 15,000 meters times 1,000 meters equals 15 million meters square. Now I'm ready to make the conversion from meter square to air. So 1 air equals 100 meters square. If 1 air equals 100 meters square, to figure out how many air is 1 meter square, we need to divide 100 meters square by 100 and divide 1 air by 100. From 100 meters square to 1 meter square, we need to move the decimal point 2 places to the left to get 1 meter square. So we also must move the decimal point from 1 air 2 places to the left to get 0.01 air. So 1 meter square equals 0.01 air. and I make sure I don't forget to square that meter. So 1 meter square equals 0.01 air, or 1/100th air. So if 1 meter square equals 1/100th air, or 0.01 air, then 15 million meters square would equal, so 15 million meters square would equal 15 million, so I make sure I have all the zeros, times 0.01 air. So 15 million times 1/100th, I just need to take the decimal point from 15 million and move it 2 places to the left. So now I have 15 and 1, 2, 3, 4 zeros. 1, 2, 3, 4 zeros, which gives me 150,000 airs. So 15 million meters square equals 150,000 airs. And I go back to the original problem, which is expressing 15 kilometers square in air. So 15 kilometers square equals 150,000 airs, and I boxed my answer. As I was rewatching this video before publishing it, I realized I made a mistake, and I want to point it out to you. When I wrote out this problem, I wrote it out as 15 million times 0.01 times A. That's wrong. The A is a unit of measurement. I did not intend to write it as if it's a multiplication problem with A. If a problem is written with the closed parenthesis outside A, that would imply a multiplication with A, and that's wrong. So I should have written the problem as 15 million times 0.01 A, with the A inside the parenthesis, because the A is a unit of measurement, not a variable to be multiplied with. Problem E. Express 2.2 kilometers square in hectare, abbreviated HA, where 1 hectare equals 100 airs. And I copy the problem down, nice and neat. And I write down the other conversion units. 1 air equals 100 meters square, and 1 kilometer equals 1,000 meters. So I need to convert kilometers square to meters square, and from meter square to airs, and from airs to hectare. So I start by breaking down 2.2 kilometers square into 2.2 kilometers times 1 kilometer. Now I convert kilometers to meters. 1 kilometer equals 1,000 meters, and I write that down on the line below. So 1 kilometer would be 1,000 meters. To convert 2.2 kilometers to meters, I need to multiply 2.2 times 1,000. So I bring that decimal point 3 places to the right, or 3 scoops to the right, and I fill those empty scoops with zeros. So now I have 2.2 kilometers equals 2,200 meters. Now I have 2,200 meters times 1,000 meters, and I write that down on the line below without the scoops so that I can see those numbers clearly. To multiply 2,200 meters times 1,000 meters, I take 2,200 and I add 3 zeros. 1, 2, 3. Now I have 2,200,000 meters square. Now I can convert meters square to airs, and 1 air equals 100 meters square. So 2,200,000 meters square, I take the decimal point and move it 2 places to the left. And that gives me 22000. I write down 000, and now I have 22,000 airs. And to convert 22,000 airs to hectares, I see that 1 hectare equals 100 airs. To convert airs to hectare, I need to move the decimal point 2 places to the left. So I take 22,000 airs, bring that decimal point 2 places to the left, and I get 220 hectares. So 2.2 kilometers square equals 220 hectares. And I box my answer. The practice problems for this lesson start on page 336 of the textbook. I strongly recommend that you do every problem in the problem set. Don't give up on a problem too quickly. Good problems will really challenge you to noodle around, and the satisfaction of solving a tough problem is very rewarding. I expect it could take several days of maybe 45-minute sessions to work through all the problems in this problem set. And as always, please check your answers with those on page 436 of the textbook to make sure you did the problems correctly. If you find yourself still stuck on a problem despite having the solution, you could go to singaporemath.com and purchase a copy of their solution manual for this textbook. I hope this video was helpful for you. If this video was helpful for you, please give me a like, subscribe, and share this channel with anyone you know who wants to learn math. Thank you for joining me at Do the Math America.